Well, welcome everybody. Thank you for coming. Welcome everybody online. We're gonna get started. It's 5:30. So without further ado, my name is Petra. I run these research support workshops here at Evans Library. And today we'll talk a little bit about coding. So the brief overview, what we're going to cover today, basically basic concept, basic elements of programming language, popular programming languages, a little bit about integrated development environment because it's important and you won't get far without that. And then we'll do coding demo in C++, Python, and Java. And feel free to dive in or ask questions as we go along. We'll cover it fairly fast because we only have 30 minutes. But as I said, you're welcome to join us during our weekly sessions on Wednesday at 6 p.m. So basic concept, what is computer program? So in general, computer program is a sequence of instructions written using a computer programming language to perform specific task by the computer. It is also called computer software, which can range from 2 lines to millions of lines of instructions. Computer program instructions are also called program source code, and computer programming is also called program coding. A computer machine without a computer is basically just a box. So algorithms, you're already kind of familiar with that. It's step-by-step procedure for solving a problem. Libraries, there are pre-existing packages. A lot of coding has been done for you, so you don't have to reinvent the wheel, so you can use those. Now bugs are errors that cause all sorts of havoc. And we know some fun fact about that. John, could you enlighten us on bugs and their history?
Oh, the reason why they're called bugs is that there was a military system in the 40s that the machine wasn't functioning properly, and they discovered the moth was ruining the system, and so they had to physically debug the system so that way it would work properly. And so ever since then, when a computer isn't working right, it's been referred to as a bug.
So now we know. All right, programming languages. So English is a natural language. It has words, symbols, and grammatical rules. A programming language also has words, symbols, and rules of grammar. The grammar rules are called syntax, and each programming language has a different set of syntax rules. So, learning to program, like with any other language, it takes practice for sure. So, learning to speak and use programming language is in many ways like learning to speak a human language. In both cases, you have to learn new vocabulary, syntax, and semantics in order to use it. Now, basic elements of programming languages. So, as I mentioned before, we'll start with programming environment, which is not necessarily part of programming language, but it's very important because it's a first step before you can actually do the programming. So, you will need environmental setup. It is based on top of which you can do your programming. We need to have the required software setup, which will be used to write computer programs, compile, and execute them. The setup to start with programming using any programming language involves a basic text editor to create computer programs. Text editor is a software that it's used to create that. My mouse escaped. You will also need a compiler, and the compiler is the program that compiles the binary format. The conversion from text program to binary file is done by this software called compiler. Another piece you may need is interpreter to execute the programs directly. There are programming languages such as Python, PHP, and Perl which do not need any compilation into binary format, and here an interpreter can be used to read such programs line by line and execute them directly without any further conversion. So as I said, I skipped a whole bunch of things. So basic syntax, data types, variables, keywords, basic operators, decision making, loops, numbers, characters, arrays, strings, function, and file, input, output. These are all this is the terminology you kind of have to pick up as you go along because you will need to understand those. We don't have time to cover each and every one of them. but just look them up a little later on. So we'll start with the coding environment. So in FIT we have a learning and research server called 01.fit.edu, which is used for submitting small projects and homeworks. This server is available to students, staff, and faculty to provide learning and research platform. And there are some specifications right here. You can read up on it a little bit on those links that are included. How do you access code01.fit.edu? Well, you need to download what it's called a secure shell SSH client. Either PuTTY or Kitty were suggested by our IT. These are designed for Microsoft Windows, but there is an alternative if you are a Mac user that John will.
The terminal utility that's already on the systems.
Okay.
You just use SSH on it.
Okay. So the window will pop up, and in a host you will need to use host name. You will need to use code01.fit.edu and log in with your Trax account and password. So a couple caveats here. You need to store your work on your drive, maps it from there, and there are different versions of programs. So you need to look up all the available package versions by using a module avail command. If you have any issues with installation or upgrades, you can just submit a ticket to our tech support. So try it out and see how it works. These are a couple snippets. So this is once you download the PuTTY, this is the login window, and then after you log in, you are in the server. It looks something like that. We will show you, we'll come back to it. John will do the demo in C++ and Python using the server. So a task that we're going to cover today is the classic Hello World program that's used because it's simple and pretty easily executable. It also serves as a check whether your environment was set up correctly, that it actually works. Then we know that computers are really good in boring, repetitive tasks. They execute them very well. While people get bored, they don't. So this is the value of loops, so we'll show you how to do loops as well. And then just for good measure, we have a temperature conversion task, because some of us are from different places, we use different temperature units. Thank you. So the popular programming languages that we'll kind of go over today are C++, Python, and Java. A little bit on C++. So it was developed by this guy, a Danish computer scientist at the Bell Labs since 1979. It is general purpose programming language, widely used for developing system and application software. If you want to read up a little more, he has his own website because it's heavily involved still with the C++ development. And anything and everything you want to know about it, you can find right there. So Python was conceived in the late 80s, and its implementation was started in 89 by another guy with fun name, this Dutch computer programmer right there. It is also a high-level general-purpose programming language used for system administration tasks. And the fun fact is that it's not named after the snake, but after a silly British comedy called Monty Python. If you haven't heard about them, then definitely check them out. Again, python.org is the website that has all the information that you may want to check out later on this language. Okay, switching to Eclipse, the integrated development environment that we will use for Java demonstration. So Eclipse is open source software you can download. You will need the plugins for different languages, and same goes for compilers and debuggers. It provides IDEs and platforms for nearly every language, but it's most famous for Java. That's why we are using it for our Java demonstration. There are other IDEs that you may want to check out, such as NetBeans, CodeBlocks, or Visual Studio. We'll kind of show them in a minute. Now a little bit on Java. So that was developed by Sun Microsystems and released in '95. Derives much of its syntax from C and C++. Java applications are compiled into bytecode and run within the Java virtual machine so that the same code can be run on many platforms. So Java is platform independent. The same program can run on any correctly implemented Java system. Now I found this handy graphic that kind of explain how it works. So a program written in Java programming language is first translated into Java's intermediate language. This is called compiling, and the software used for this is called compiler. The program is then executed on Java virtual machine, which interprets the intermediate language on some target computer. An intermediate language lies between programming language, which is understood by humans, and machine language, which is executed by a computer. An intermediate language is interpreted by a certain software generally called an interpreter. A virtual machine is a software that pretends to be a computer. So this is a little bit on Java. Now here you have a side-by-side comparison of Hello World program. So you kind of see they differ, but some components stay the same in terms of syntax, and with clearly Python being most efficient in that task. Now we have a couple suggested readings that you may want to check out. You get them free from the library. Just use your Trax login. So this is a detailed series for C++ and Java. And there is also O'Reilly Media ebook for Python that may come handy. I know that you may have tons of questions. We are breathing through it really fast, but I just wanted to bring to your attention that we are meeting every week. If you have questions or you want to shoot me an email and give me a suggestion for next topics, here are my information, just grab them, okay? Now I will switch over to John to actually do the programming. Okay. You want to switch, or you just want me to?
Right here.
Yeah, this works?
Yeah. Okay.
I moved everything is on there. You just need to minimize and maximize as you go along.
Sure.
Yeah, maximize it if you can. Thanks.
All right.
So this is the code 01.fit.edu server.
All right, and I'm just going to remove everything that was in here. Okay, so start off with the C++ one.
Yeah.
All right.
And kind of narrate as you go along. So what did you type in so far?
What I did was I just made a directory of C++, so that way all the C++ code is in this folder. So first thing I'll make the hello world .cpp, and Nano is a text editor for the command line. So for C++, you need to include and what IOStream allows you to do is it allows the program to actually output something to a command line, or allows you to input something from a command line, rather than having to recreate all of that. So every program needs a main section, and it needs to be able to exit, so return 0. And to output, you use cout, you quote it, hello world, and this will put a new line character so you don't have it running into the next prompt. In Nano, everything is on the very bottom of how to use it, so that caret means hitting the control button, and so Control X will exit out. Do you want to save? Y, yes, and Enter will save it. So that's the hello world file written out. To compile it, You can use GCC's C++ compiler, which is G++. Just have to compile it like that and create the binary or you name the binary by calling -o. So hello world, and that will compile it. And then you can run it just by doing that, and it outputs hello world. Okay, next one was world. Okay, so the next one is creating a loop. One of the ways you can loop is by using the for command, and what that will do is it will keep looping until a condition is met, or until a condition is no longer met. 0 is less than 5, and I. And so what this says is that I'm using a variable called I, and I'm going to check every time if I is still less than 5, and every time that this happens successfully, I'm going to increment the variable by 1. So eventually it will no longer be less than 5. And you can see it incrementing by putting it into the output stream. These double angle brackets connects different strings together. That's why those are in there. So I'll exit out of this and save it, and I will compile that. Oops, output. And then by running it, you'll see that it keeps going out until it hits 4. When I was 5, the condition failed, so it just exited out. And now 2 and let's see. Okay, so for doing a temperature conversion, this is to show doing or outputting with some sort of math happening in the background. So what I'll do is I will set a variable. Double is a type of value that has a point value to it. Since temperature conversion usually you end up with a decimal of some sort, you usually need one for that. So let's say it's 78 degrees outside right now. I haven't checked. What I can do is two. F minus 32. And so what this will do is it will output 78.0 Fahrenheit is equal to, and then we'll do the math, evaluate that, and then output it. So you'll see that F is equal to that value in Celsius. And exit out of there, save it, compile.
G++ is the compiler?
Yeah. And run it. And so 78 degrees Fahrenheit is equal to 25, and then some.
0.5.
Yeah, 5. Yeah, okay. and so that's how you do that. By comparison,
So changing directory.
yeah, I'm going to make a Python directory. All right, so world dot, and the hello world for this, as was on the screen before, is just simply hello world, and that's it. You don't compile Python. You actually there's just a command Python, and you run it directly. So that's all there is for that. Loops look a little different in Python. Rather than using for or for with the bracing, let me turn that before I start talking.
You're just editing that.
What I did was I copied it off just to have a frame of reference for what I was doing. It was for I in range 5. World plus I. Alright, that should be it. Yeah. That was not it.
Oh, you need the 2 dots.
Oh, that I always forget those colons, yeah.
So what's the str column?
Oh, that's string. To make sure that print is actually being passed a string value, what you can do is wrap it in that str. That will ensure that you're actually getting a string being put into the print command. If you use a float, like if that was a floating point variable, it sometimes does not like that and will error out. Okay, and there we go. And so then that recreates what we did in C++. And then for temperature, that was temp.pi. Use f as that value again, and float. What did I say, 78? Something like that. Should be about 25 Celsius. Okay, so so that was F, right, str Fahrenheit in 2, and like in C++, the function that connected all those strings together was that double angle. In Python, it's a plus sign. And then you can just do the equation here. Make sure it outputs as a string. And so, you know what kind of that is. Okay. And so that should do it. So Python. Yep. One thing I should point out, the Python code looks a lot shorter. It's a lot quicker to write. It does come at a bit of a cost though, because if you see time, say for on that loop, Python versus and that was loop. How it takes 0.032 seconds versus 0.004. It took 8 times longer to run the Python one. So if you're making anything that's going to be doing a lot of math behind it, it starts to build up. Because if you had something that would take a day to run in C++, it would take 8 days in Python. So just
Keep in mind.
yeah, scripting languages are shorter to write, but they come at the cost. They're generally slower. So
And how do you switch between the compiler and text editor and compiler?
what I would between like the command line
Yeah.
and I was just running Nano.
So you go Nano, and now how do you go back to server?
In the bottom left, how it has that caret X exit. That means you hit the control key and the letter X.
And it returns you back.
Yeah.
Okay, great. So now
Okay.
switch to Java.
There it is.
Could you maximize?
Sure. Okay, so if you have a larger project where you need, it's going to take some actual effort to track all of the source files and all the code in the project. Using an IDE is a good idea, just so you don't get too lost in your own project.
But there is a caveat that you always need to try the code on a code server if you need to submit it.
Yeah, if this is for a homework or project and an instructor has the requirement that it has to be able to compile on the Code 01 compile server, then you always want to be able to check that as well. Because it's not guaranteed to compile just because it works in here. So if you need to make an entire project, you can set up one through here. Two. Since there already seems to be one. Right. And with Java, you need to put all of your code into to start off, you need to create a class file. Main. Since this is the main of this project, in Eclipse it will actually already set up the whole main structure for you just by hitting that check mark and finish, and it will generate the code for you right at the beginning. And so all you really have to do here is, for a hello world, is just system dot out dot and line.
You see the added advantage that the Eclipse is trying to help you out to finish the.
Yeah. It's explaining on the right how it explains what method you're calling, what arguments it will accept, and you can go through its little wizard here.
Like visual.
Yeah. And so, it also does the closing braces automatically. Like how I typed in the open parenthesis, it closed it too. So if I hit the double parenthesis, it makes the other one and it sticks your cursor right in the center. So hello world. semicolon. With Java, generally Eclipse is building it in the background. So while you are supposed to build Java, it's already done it.
Because you saved it as you go.
Yeah, I hit save and it knew to compile it in the background. So all you have to do is just run it, and it will pop up a console. Eventually, there it is. And there is the hello world output. And one of the other things you gain out of using an IDE is that you can see your program at a conceptual level of all of, like, the classes and methods like that, and what the arguments are.
Do you want to do loops?
Oh, yeah, right. Okay, so for doing a loop in Java, it will look just like the C++ one. So you have to put some braces. Where's end? Around it. And I is equal to 0. I is less than 5. Then I plus plus. Then I, and that should do it. So then running it again, and it outputs all of those strings. Then for a temperature conversion, oh, and while you're typing, it's constantly checking to see if you're typing it correctly. So how these little X's come up on the side, it's informing me that my bracing is all out of order because I have this extra one here. And so that will fix that. And I have an extra quote here. All right. 78. And F. Right is equal to F minus 32 times 5 Celsius. And that should output the 25 5 repeating.
Nice.
Yep.
All right. We kind of went over with the time a little bit. So if you have questions, just hang in here for a minute. I will say goodbye to our online viewers. Thank you for joining us.